sprint from the brink of disaster to the Zen of Pacemaker.
Thank you. So we're going to be doing this like two people, or really three people that we have here. My name is Florian. This is Tim, and we also have Andrew Bickhove from Red Hat sitting in that third row over there. He happens to be the author, creator, and lead maintainer of Pacemaker. So if we get any questions where we're out of our depth, or or situations where stuff just doesn't work as documented, we have a throat to choke. So that's quite useful. So a few words about, I guess we should say a few words about ourselves. My name's Florian. You may have seen me in Brisbane last year. Back then I used to work for Linbit. Since then I have co-founded Hostexo, which is an independent high availability and distributed storage consultancy. Tim has also changed company affiliation nominally since Brisbane, because back then he used to work for Novell and now he officially works for SUSE again. And Andrew was... say again?
He's shaking his head, don't ask.
And Andrew used to work for Red Hat then and is working for Red Hat now, but he wasn't in Brisbane. Right?
Just to make it...
Yeah, LCA last year. Okay. All right. So, we put up the instructions for the tutorial on the tutorial wiki page. This is just the Google short URL. You are entirely free to follow along our steps as we go, or just watch today and replicate the setup whenever you return from LCA, and you do that in the comfort of your home or office or home office. That's entirely up to you. I think you're going to take something very useful away from this tutorial, no matter which path you choose. A few words on the organization of our slides. We're using two different slide layouts here, so just so you know exactly where we are in the talk. We have one layout which is like this. That's the one with the blue bar to the left. And it means, would you please treat us to the courtesy of your kind attention, is a line that I stole from a BMI pilot, which he did when they launched the security ballet on a flight. And I thought it was kind of a nice, British way of saying, shut up and listen. You don't have to shut up, actually. Listening is fine. And of course, if there's any questions that you have throughout the talk, then please fire them at us immediately. We have a bit of a shortage of mics here, because Tim has the lapel mic, because he's going to be doing much of the typing. So we only have this one handheld. So just so everything gets picked up in the recording, when you have a question, please put up your hand. I'll be sprinting toward you, trying not to trip, and put the microphone in your hand, and then we can take the question and tackle it immediately. And then we have a slightly different layout, which is the one with the horizontal bar, and that's do something, right? So we're having these little instruction bits and pieces where you actually get to do stuff on your cluster. All of you have access to a virtual environment, which we made available to you prior to the talk. And Rob Thomas was nice enough to actually set up a mirror for the VMDK images, so not everyone has to download from Dropbox. What these are, it's basically a virtual two-node cluster of two Debian machines, Debian squeeze machines. Of course, we know OpenSUSE is wonderful and Fedora is wonderful as well. And you can run Pacemaker on all of these platforms, and on SLES, and on RHEL, and on CentOS, and on what have you. It's just that we had to select one, and we selected Debian. That's it. So these are two boxes. They're named Alice and Bob. They both have two virtual network interfaces, of which we're going to use both for cluster communications. One is the connection to the sort of public switch network, which is the one that your clients would be connecting to, and the other is the one that we're using for storage replication with DRBD. And we're going to use them both for cluster communications. And these virtual machines both have two virtual block devices. One is where the OS is installed, and the other is the one that we're using as our data volume and that we're going to replicate with DRBD. You will be able to shell into these boxes if you have them properly set up. The IP addresses would be 192, 168, 122, 111, and 112. 111 is Alice, 112 is Bob. You can shell in as root. The password is hastexo, H-A-S-T-E-X-O. Sorry for the shameless self-plug. And you're, of course, free to put your own secure shell public key into the .ssh authorized keys or authorized keys 2 file in order for you to have passwordless login on these machines. So that's about it for the virtual environment. As I said, not a requirement for you to set it up. But if you want to follow along, then that would be helpful to have. If you don't want to follow along now, you can set up the virtual environment at any time. They're going to be in that Dropbox account for quite a while. I would estimate at least 1 month past LCA. So that gives you plenty of time to download them and run them, because we're not supposed to say deploy anymore, and run them in your own virtual environment. All that's required is essentially is libvirt and either QEMU or KVM. And we also have VMware images and VMX files, although there's clearly no warranty on those. So there might be a little hacking and fixing that you need to do to get those running. Most of the time, they work fine. If they don't, please talk to your VMware experts and go. Avi had a question. Okay, so Avi's saying the VMware images boot fine, and we're happy with that. Awesome. So in other words, if you're failing at it, go talk to Avi, and he's going to help you with them. Okay. Do we have another question over here? Yes? Awesome. So VMware Workstation works fine as well. The only platform that I've actually heard people report problems with are some versions of VMware Player. So Workstation and Server, and actually also importing stuff into ESX should work fine. And evidently VirtualBox is working fine as well. You might have some issues with VMware Player. Okay. So a very, very brief overview of the Linux high availability stack. First off the bat, we have quite a number of familiar faces in here, of whom I know that they're very familiar with the Pacemaker and Linux HA stack. Can I just have a quick show of hands on who has deployed this stuff in production before? Okay. Okay, quite a few. Just out of curiosity, who's using what used to be called Red Hat Cluster Suite, and which now has the much more concise product name of Red Hat Enterprise Linux High Availability add-on? Who's using Red Hat Cluster? No one? Okay. Clusterware? Yes, there's one. Okay.
Anybody using the similarly named SUSE Linux Enterprise High?
Oh yeah, I'm sorry. Yeah. But it's actually not SUSE Linux Enterprise Server. It's just SUSE Linux Enterprise High Availability extension, right?
Yes.
Yes. Okay. So that's. But you are.
So it's not for servers.
Say again?
So it's not for servers.
It's for anything. You know, it's like. There's probably a SUSE Linux Enterprise smartphone. High availability, whatever.
We can't talk about that yet.
Okay. So how does this? What does the stack look like? What is it that we use in order to make applications highly available? Basically, I always go through this from bottom to top, and I'm seeing that we don't actually have still a contrast on that display here. Sorry about that, but I'll go through it anyhow. So at the bottom of the stack, we typically or very often have some form of storage replication. Not necessarily. We can also do clusters with single image storage, but that basically means that you're introducing a SPOF into your design from the get-go, because you have this one single data silo. That if that basically turns to shreds, then all of your other HA comes to naught because you don't have any data to serve anymore, which kind of defeats the purpose. So very often we have storage replication. There's multiple ways of achieving this. There's proprietary solutions like you may be familiar with IBM Metro Mirror, or there's NetApp Metro Cluster, there's EMC SRDF. And we have a number of, thankfully, we have a number of open source solutions. DRBD is a block level replication service, which incidentally is also going to be the one that we're using in our setup here. But there are file system based replication functionality that you can use, such as Gluster, and there's a few others. So most of the time we have some form of, oh, and by the way, we could also be using some application-specific data replication, such as a MySQL replication or Postgres streaming replication, or anything of that nature. It doesn't necessarily have to be application agnostic the way DRBD is. So that's sort of the bottom of the stack. The next thing is we've got a cluster messaging layer. So that's a reliable message passing layer that we use for nodes basically to communicate. And it's not just that. It's not just reliable message delivery, but it's also things like establishing the cluster membership, as in what nodes are currently members of the cluster and behaving well. And we also have the establishment of cluster quorum at that layer. On top of that, we have cluster resource management. And contrary to what Karen was complaining about in the keynote, now we have a pacemaker that actually does run open source. It's kind of nice. So this is the stuff that basically keeps our cluster resources going. We don't really have a formal definition of what a cluster resource is, other than if the cluster manages it, it's a resource. And that can be something like very, very simple, like a floating IP address that moves between cluster nodes. It can be a file system that we mount as we need it on individual cluster nodes. And it can be something reasonably complex, like a database, right? Like MySQL, Postgres, Oracle. We can keep all of that under Pacemaker, or under the auspices of a cluster resource manager. And Pacemaker is the one that we're going to be using. Like I said earlier, there's others in the Red Hat cluster stack. That would be RG Manager. Avi will probably be able to tell us what the equivalent in Oracle Clusterware is.
It's all clusterware.
It's all Clusterware, okay, so it's this big monolith, Borg, collective, Death Star thing. And that's the kind of stuff that keeps, not only starts and stops resources, but also monitors them, keeps them alive. When there's bad things happening on one of our nodes, but we still have healthy nodes that we can still use, this is what affects our cluster resource failover. And is the kind of stuff that generally keeps us happy. And it keeps us happy because it interfaces with what we actually really care about, and that is the application that we want to keep highly available. And we currently have, what is it? I think we have about 70 resource agents that ship either with Pacemaker or with some third parties that we can thereby make highly available. Like I said, from a simple IP address over a file system, databases, whole virtual machines, messaging servers, yada, yada, yada. So we have a pretty long list there. And what we're going to be using in our example configuration today is the application that we're going to make highly available is MySQL. Why? Reasonably arbitrary. We could have chosen any of the other 70 resource types that we can manage. Why do we use MySQL? Simply because it's a service that pretty much everyone who's ever done any sysadmin work on Linux will have touched sometime in their career. So we can estimate that people are probably going to be familiar with it. Anyone not know what MySQL is? Okay? Okay,
They're too embarrassed.
Huh?
They're too embarrassed.
Yeah, probably. They probably are. Okay.
It's a milestone or something.
Can be.
Do you have any?
With beer.
Okay, that'll work. Okay.
Wow,
Yeah,
nice.
Yeah, the contrast really sucks.
Is there a whiteboard marker?
Is it what?
Whiteboard marker.
There is a whiteboard marker, but then we're...
Well, no, I can scribble a picture on the side.
Yeah. Thank technology. One would have assumed that in 2012 this is a problem that would be solved. Now, let me walk you through this. And just so I feel your pain, I'm going to walk up here just to see how bad this really is. Wah! Okay, note to self, black arrows next time. Okay, so what we have here is we've got basically two physical hosts that are running our cluster services, DRBD storage, etc., and those. Yes, thank you. Could you cartwheel? And one of these is always basically the active node from the cluster perspective, and it acts as our MySQL master node. Okay, and then down here we have a number of either MySQL slaves or downstream application servers that just use this MySQL master node. And then, of course, the configuration or the topology can become arbitrarily complex. What's nice about this is now that we've got all of this running on one node, we can then simply fail over that MySQL master to the other node. That's a very simple command, one command that we do in the Pacemaker shell, and everything moves over. And what's nice is because DRBD makes sure that this service sees exactly the same kind of data on both of these nodes, and we have a virtual IP address, a floating IP address that this MySQL master node binds to. I'm sorry, the MySQL master service binds to. Beyond this failover, there's literally nothing else that we need to do. It's a completely transparent kind of failover. The slaves and the downstream app servers will just continue to talk to the same IP address, which now, by magic, just lives on a different node, which we don't need to care about because we make sure that everything is exactly identical on that node. So let's start first with DRBD, and this is where we actually get into practically working on these boxes. In all of these title slides for the technologies that we're covering, there's two links in there. One is a very quick, it's like a one-page write-up that we happen to put on our company website, which is just a very, very quick rundown, sort of the elevator speech for all of these technologies. It's just one screen full. And then the URL on the bottom is the official project website. So DRBD is a storage replication technology that allows us to replicate data at the block level. It's that simple. And we can use DRBD in any way, shape, or form that we normally would use any other block device. What's nice about DRBD is that all of the data that goes into it is being synchronously replicated over to another node. That is to say that whenever we write something to this device, that write does not complete until it's actually completed on both nodes. And because all of this happens at the block layer, that is to say, like relatively low down in the Linux I/O stack, all of this is remarkably efficient and comes with really, really impressive performance. So there's a very, very, very little overhead for using DRBD. And now Tim will assume his position here, and we're going to just do a quick switcher over. So what we're going to start with is we're going to set up, what's this noise? Oh, gone now, okay. What we're going to, and by the way, OpenSUSE is great too, in case I forgot to mention that. What we're going to do is we're going to set up a DRBD resource which we're then going to use as a file system, and that file system is going to be used as the MySQL data dir, the stuff that we mount to varlib MySQL. We just make sure that this stuff is now on replicated storage. Now, in order to set this up, you're going to have to log into both of your boxes. Did a whiteboard marker eventually turn up? Lovely, thank you. So, and that is a whiteboard marker, yes. That's like the most embarrassing thing that you can ever do at doing a talk when you're taking a Sharpie and writing on a whiteboard. So, 192, 168, 122, 111, that's Alice, and 112, that's Bob. Those are the machines that you now need to shell into. And those will be running in a virtual bridge. And luckily, Tim already has that set up and connected, and everything is wonderful. So there is a central configuration file to DRBD. Happily, it lives in /etc/drbd.conf. And that is really just a skeleton that includes anything that's in etc drbd.d. So that's like a few defaults and yada yada yada. Not really particularly interesting to us at this point. This is basically as it ships. But what we want to take a look at is the mysql.res configuration. Okay.
Can everybody see that? I can make that bigger if you need me to.
And look, we've got good contrast. It's just black on white. A DRBD resource definition is actually very, very simple. We need to assign a unique resource, and by the way, you find all of these in your configs as well. So just go in cd into /etc/drbd.d, and you will find that in there as well. So it's very simple. We've got the resource MySQL, which we just need to set, and basically an arbitrary resource name. I think it can be any name with up to 64 characters. It has to be US ASCII, and it shouldn't contain white space, if I remember correctly. We then define, okay, what's the DRBD device that we're going to be managing with this? In this case, it's just going to be dev DRBD 0. In case you're interested, all DRBD devices have the Lanana registered device major number 147. And then it's DRBD 0 is the minor 0 and so forth. And we also need to define, okay, what is my actual local backing storage that I want to replicate? That in this case would be the dev SDB1 partition. And this metadisk thing is where DRBD stores its own DRBD-specific metadata. So DRBD itself needs to store a little bit of persistent metadata on this backing device. In case you're wondering how much that is, it is about 32K per gig of replicated storage. Okay? And then we simply define, okay, we've got these two nodes, which have to be identified by name here, and you identify them by name just as the uname-n output for those nodes. Why am I mentioning that? On Debian and SUSE and a number of other platforms, that is just the unqualified host name. As we're seeing here, that would be Alice and Bob. If you're running this on Fedora or CentOS or RHEL, then uname-n is actually by default the fully qualified domain name, in which case you would put the fully qualified domain name here. We're telling it to replicate, in this case, over a separate dedicated network. So the 133 class C subnet is mapped to the F1 interface, and that's the one that we're going to be using to replicate. By convention, although this is not registered anywhere, by convention, DRBD uses replication ports from 7788 forward. And you need to have a uniquely identifiable socket, replication socket, for all of your DRBD resources. That is to say, you either reuse the IP address and then put different ports, or you just use multiple IP addresses with the same port. The former option is the much more common one. So what we're telling DRBD here is, when you're configured, you're going to be managing the device dev DRBD 0. Its backing device is going to be SDB1, so that's the data set that you're going to replicate. You're going to set aside a little bit of space at the end of that device for DRBD metadata, and you're going to be replicating over these addresses on port 7788. That configuration needs to be identical on both cluster nodes, and that is exactly what's already the case for your virtual machines. Now, what we need to do is we actually need to fire this thing up. And before we do that, we at first should check whether we actually have that SDB1 partition that we want to replicate over. And it turns out that we don't. Okay, so let's create it. You can create that using whatever tool of your choice. On Debian, I tend to like to use cfdisk, but you can use fdisk or whatever it is that you prefer. So we're going to partition def SDB1, and on this we're going to create a one primary partition, 1 gig in size. We want to make that primary, exactly, and then 1, right, and then I think that's plus 1 gig actually in regular fdisk.
Plus 1 GB in capitals.
There you go, and then, whoops, and then W for write. Okay, and that's it, okay? And now it's here. And now we can, use our one-liner scripting ninja by doing an sfdisk-d dev sdb and pipe that to ssh bob sfdisk -- force. There we go. Oops, sorry, no, kill that. You have to give that another def sdb at the end.
That would be a good idea.
Yeah, def sdb. There we go. And say again?
DNS
No, it's
time.
not DNS. It's actually GSS API that for some reason is enabled in Debian secure shell config or whatnot.
Yeah, I think the result comp is wrong. I think the result comp is wrong. I had to change it on my system.
Oh, really? But that's actually in etc hosts, so it actually shouldn't be looking up anything. But oh well. So there we go. Okay.
The
I'm also getting IP6 timeout on the wide network because it's trying IP6 first and it's not globally relevant.
Ah, yes. Have we mentioned that the IPv6 UX on Linux sucks and someone needs to fix that? That may not be entirely new to you. What we've created is an SDB1 partition on both of these, on the SDB device on both of these nodes. So we now have everything in place in terms of prerequisites that we need to set up our DUBD resource. Now, since I already mentioned, DUBD uses a certain amount of internal persistent on-disk metadata for its own purposes, and it doesn't just pull that metadata out of clean air. We have to create it. We have to create it once on both of the nodes, only once in the lifetime of a DUBD resource. And that's what we do with the DUBD atom create-md command. By the way, you are complete. Oh, and we have bash completion for that thing as well. So it's just DUBD atom tap, and then you get an.
Do I need a mod probe here first? Do I need a mod probe
Nope.
here first? No.
Excellent question. The metadata creation is something that happens entirely in user space, and we don't even have to mod probe the DUBD module for that. So DUBD atom create MD, and then the resource name. That will be MySQL. There we go. And this is not exactly spectacular because what it does here is it just creates it, and everything is fine. But there's actually a significant amount of intelligence built into this command. It will actually take a look whether there's data currently on this device, and if it, say, detects an ext3 or XFS or even a riser file system signature, it will then check, okay, is this command still keeping enough, do we still have enough room for on the device in order to create the metadata? And if not, rather than silently wrecking your file system, it's going to tell you, and it's going to tell you, okay, I don't have enough space on this device. I would be overwriting the tail end of a file system. I'm not going to do that. Please either resize the file system, as in shrink it, or resize the underlying block device, as in enlarge it, which is something that's easily done with, for example, LVM. And it also detects things like LVM, physical volume signatures, and things like that. So it's reasonably intelligent. Right now, all of that intelligence is basically wasted because we have empty devices to begin with. So we just create this metadata block, and we're happy. And we do the same thing on the other node.
That answers yesterday's file system talk when the XFS guy was saying, why would you ever want to shrink a file?
Yeah, that's a good use case, yeah. So we now have a set of metadata for both of these on both of these nodes. The metadata is always, when we use metadisk internal, it's always at the very end of the device. That is to say, if you ever choose to kick DRBD out, then you can just mount the underlying backing device, and it will just detect the file system superblock on that, and everything will be fine. So there's no additional modifications that DRBD makes to that underlying device other than putting a little bit of data at its very end. So we can now bring this device up, and this is where we need to mod probe. By the way, mod probing DRBD is of course not something that you always need to do manually. That is something that the cluster manager will happily do for you, as we shall soon see. So we mod probe this thing, and I suppose you did that on both nodes.
Yep.
Lovely. And then we're using the DRBD atom up command to bring this thing up. No, not Maestro res, just the resource name. There we go. Okay.
Sorry.
Just a second. We do that on the other node as well, and I'll be happy to take the question.
No, just there's a typo in your walkthrough.
Oh.
It says DRBD admin up DRBD instead of IC.
Oh, sorry about that. Okay, thank you. I will fix that. So it's DRBD atom, which is the binary, and then up, which is the subcommand for that binary, and then goes the resource name. Or alternatively, you can also do a DRBD atom up all, in which case it will just up all of the resources.
So you can't name your resource all.
You shouldn't, really. You also should not name your resources master or slave, or active or backup. You should also not do that with your nodes.
I'm just about to push a commit to
Yes,
now.
because it's going to be real fun when it's 3 a.m. on January 1st and you're terribly hungover and your phone goes off and you need to fix a system where you now have DRBD in the secondary role on a master node named slave. Good luck with that. Specifically when you're trying to explain that to your coworker on the phone who's still sober. So now, it's up, and we can now interrogate the status of this DRBD resource by just looking at the proc DRBD virtual file, which is what almost stopped DRBD from ever getting merged because Christoph Helvig was freaking out about doing something new in proc. But it's good now, I guess. And this is the expected state that we get out of a freshly initialized DRBD device. It is connected, that is to say that the two nodes are happily talking to each other. It is currently in the secondary role. So what do we mean by that? We have two roles in any DRBD device, primary, secondary. With the primary, we can basically do anything. We can read from it, we can write to it, we can do whatever the hell we want. On a secondary, it's just there, and it receives updates from the other side. A question that we get relatively often is, why does it not let me mount this thing read-only? The secondary, that is, if you're wondering about that, please Google for cache coherency, and you'll find out. It's just not a good thing to have a file system that is mounted read-only with something else modifying the underlying block device. It's just not going to work. Okay, and our disk state here is inconsistent. What does that mean? The poor thing does not yet know what its good data is. Okay, we can always add a DRBD resource after the fact to a backing device that already has data. In which case, we have to tell DRBD, okay, sync from here to there, because you've got all your precious data here, and now you're adding DRBD. And you've got a blank disk on the node over here that you want to become, your second mirror. And now if you told DRBD, oh, by the way, this over here is the good data, then you would be overriding all your precious data with blanks, and that's not what you want. So in this case, however, we don't give a flip because the storage has been completely freshly initialized. So we have a facility to actually skip this initial sync, for which we have an extraordinarily useful and terribly usable command, which I will now spell out, which is drupt atom. By the way, you're welcome to pronounce it drupt because that's just shorter. And in that case, by the way, linguistically, the R becomes a vowel because a vowel is defined as any sound that can bear the stress of a syllable. So in that case, drupt R vowel. I digress. So that would be DRBD atom -- space -- clear -- bitmap space new -- current -- UUID and then resource name. There you go. Isn't that lovely? You know, we could have a.
I thought you were joking.
We could have a DOBD atom, you know, force, skip sync, whatnot. But this is how it works. Okay. You don't have to worry at this point. What are UIDs? How DOBD uses them internally? It's very, very interesting if you're interested in that. But we're just rotating our UIDs at this point, and we're also clearing the quick sync bitmap just for background. Okay. And now that we have that, we can take a look at proc DOBD again. And lo and behold, everything is up to date. Okay? So
Fastest sync in the world.
Yes. So we actually have virtual super express infini-duper band between these. And it will actually sync faster than the speed of light. If you saw any Cherenkov radiation here, that's what it was. So everything is now fine, up to date, blah, blah. And at this point, we can now also make the device primary on any node that we please, but just on one, because it's a single primary device. So that would be a DOBD atom or dripped atom primary MySQL, at which point it is now primary. And now we can do anything that we freaking please with this device. In our case, what we're going to create is a file system, because that's what we're going to use as our, we're just going to use it as regular MySQL data storage. So we're going to do ext3, because we're boring. And we put that on the dev DOBD0. And arguably in this virtual environment, that's going to be slow because makeFS and fscheck on ext3 are slow, and our replication network here is slow, and our virtual disks are slow, and everything else.
But that's okay because Dave Tuner's not here.
That's, yeah. And I think Debian doesn't yet ship with butter. Sorry, Avi. So,
Butterface is useless for MySQL. Very quite frankly.
Okay. If I were China, I'd say, okay, what's this useful for? But nah, I'm not. Let's not go there.
Dave and I decided that Butterface for root and XFS be MySQL data.
Okay. All right. So while this is chugging along, this is of course also something that you only need to do once. So you've initialized the DOBD resource, you're creating a file system on it, and eventually what we're going to do is we're going to initialize a MySQL database on this thing. Okay? So let's let that do its thing for now, and let's focus on something slightly different. Can you pull up the chorusing slide? That's DOBD, and we've done that, and here's chorusing. Okay? Again, brief write-up on our website, and if you're interested in all the gory details, go to www.chorusync.org, where you are you going to find any documentation? You might find an FAQ. Chorusync is a messaging layer. It implements the Totem protocol. There's a lot of research papers on Totem, which you're going to love. And it's developed by a development team headed by Steve Dake, or as he likes to be called, Steak, from Red Hat. It grew out of the OpenAIS project, which was an attempt to implement a design by committee specification for an application interface specification for highly available services. Let's not go into history too much because it's painful. What chorusync ultimately does is it allows our cluster nodes to communicate and pass cluster messages, establish membership, and establish quorum. It has 2 configuration files of relevance. Both are in, no, actually 3. Both are in /etc/chorusync or subdirectories thereof. In your /etc/chorusync, you are going to find a chorusync.conf, and we're going to pull that up real quick just to go through that. That is also available on both of your nodes. Nothing too spectacular here either, except for one thing. Chorusync is, of course, capable of doing redundant communications across multiple cluster communication links. And so we're defining these 2 rings here. And we are using what chorusync calls the redundant ring protocol. In other words, a means of failing over between rings. We're going to use the active RRP mode here. And we are communicating over UDP multicast. In this case, we define a multicast group, one multicast group per ring. And we highly recommend that you use RFC 2365 compliant multicast addresses. That defines administratively scoped multicast, which basically specifies use something in the 239.255.x.x pseudo subnets, which is what we're doing here. Just in case you're also the guy who operates the firewalls at your shop, it actually uses that multicast port for UDP communications and that port -1. So it will actually communicate over UDP ports 5405 and 5404. Okay? That's just, don't ask why. Well, you can ask why because it's basically two-way communications. That's just the way it is. We also use secauth equals on, which means that we are using mutual node authentication with cryptographic hashes. And for that, we have another file in that same directory called authkey. And that can be basically any 128-byte arbitrary secret. So I just generate them out of dev-urandom, but you can also...
There's a chorusync keygen.
Yeah, there's a chorusync keygen which actually reads from dev-random and will therefore block if we don't have cryptographically secure entropy on the device, on the node at the time.
Haveged, or however you pronounce it, HAVEGED daemon is a entropy gathering daemon that useful.
Yeah, in that case, it's, however, totally useless to actually have like some. Well, anyhow. Yeah. But you can also use, feed face dead beef repeated a few times if that's your preferred secret. These config files also have to be identical on both nodes. Which is the case for you at this point. And what we can now do is we just start the chorusync daemon on a Debian box that is either /etc/init.d/chorusync start or it's service chorusync start, same thing. We do that on both nodes. Okay, anyone worked with Pacemaker 1.0 as opposed to 1.1? Okay. In the Pacemaker 1.0 series, the Pacemaker daemons themselves would be children of the chorusync process. And that meant that you didn't have to do anything other than start chorusync, and it would start Pacemaker or several Pacemaker-related daemons as its children. In Pacemaker 1.1, we have the ability to use what we call the Pacemaker master control process. And that comes with a separate daemon, Pacemaker D. We have a much more lightweight chorusync Pacemaker integration, and we also don't have, I think it was threading issues that prompted you to actually do that.
Yeah, deadlocks related to forking from a threaded process.
Yeah, okay, so for the recording, that's deadlocks related to forking from a threaded process. With the new Pacemaker MCP, we don't have that problem anymore. We configure chorusync to use this new method of Pacemaker integration by the chorusync service.d pacemaker service definition file. It's right here, yes. And if the service is just Pacemaker, the service name, and if we use version 1, that means that we're configuring the chorusync part of the infrastructure to use the Pacemaker MCP. If you use version 0, then all the Pacemaker stuff gets loaded as chorusync plugins and thus as chorusync children. And plugins are going away anyhow, aren't they? Yeah, so that's not going to be supported for that much longer. You definitely want to be using the version 1 thingy. Except if, no.
Except if you're running SUSE. We never had that problem on SUSE. I don't know why. It's just awesome.
Yeah, we went for it. It'll remain supported in... If you're using chorusync 1.4 or less, it will still be supported. We're not going to remove it from Pacemaker. But if you're running against chorusync 2.0 plus, then it all goes away.
To that, I'd like to add using chorusync 1.4.0 plus is a really, really good idea because prior to that, it didn't have ring recovery. So rings would not automatically recover if they broke and then got reestablished. And in chorusync 1.4, we finally have that functionality. So please use chorusync 1.4 by all means until chorusync 2.0 comes out and the bugs have been stamped out. So that's that. As you will be able to see from a simple PS, at this point we only have the chorusing process running. And where's our chorusing?
It's a good question.
Up there. Up there. Okay? It's just chorusing. There are no pacemaker-related daemons running at this point, but we can already interrogate what chorusing knows about the cluster state at this point. First, we're going to figure out, okay, are our rings healthy? In other words, are we communicating nicely on the network? We have chorusing CFG tool with the -s flag for that purpose, and it's going to tell you what is our current ring status. You should, when we've got a healthily communicating cluster, we would always see the status ring 0 and 1 active with no faults, and that's fine that way. Okay.
Question in the front.
Yeah.
Yes.
What's the significance of that version number in the service thing again? You had version 1 there.
Yeah. So if you're using version 0, then you're using the old style method of all the pacemaker daemons being chorusing children, which means that you don't need to start any pacemaker daemon separately.
Okay.
But you're running into the locking issues that Andrew mentioned, or you might potentially run into the locking issues.
To use version 1?
It's been supported since pacemaker 1.1.3, I think, right? When did MCP come in? 1.1.2, 1.1.3, something like that? I think it was one. Yeah, I'm not sure, but it's definitely 1.1.3 plus definitely does support it. I might have come in 1.1.2, but
it's like a year.
yeah.
Took about 2 years.
Yeah, the current pacemaker version, by the way, is 1.1.6, and most distros ship that. So, or current incarnations of most distros ship that. Relying on this too much, there's a bit of a caveat, which is if chorusing starts up and it never sees its peer, it basically forms a one-node cluster in which all rings are healthy. Which is logical, but which simply means that you shouldn't rely on the chorusing CFG tool output alone. But we can also interrogate the chorusing object database, which we do with chorusing objctl, and we grep for member in that one, member or members. There we go. And you should be seeing both of your cluster members here in that output. Okay. So in that case, we're seeing these two nodes. It actually, chorusing really doesn't care about your node names at all, but it will give you the interfaces that it is communicating over. And both of them should, of course, have the status equals joined. Okay? So now we have, what we already have is a working chorusing cluster. So as far as chorusing is concerned, everything is already operating normally. And now the only thing that we still have to do before we can actually start adding resources to everything is to start the pacemaker services. And in the pacemaker MCP configuration, pacemaker comes with a separate daemon, and that's pacemaker D, which is what we're going to start next after I take this question.
Can you explain the relationship between chorusing and a thing called heartbeat?
Yeah, that's easy. There is none. For those of you who never touched Linux clustering until about 2 years ago, the Linux HA project, linuxha.org, has an over 10-year-long history. It came with both a cluster messaging layer, which is called Heartbeat, and it came with a cluster resource manager on top of it, which never really had any name. It was basically just a monolithic thing. In an HA architecture, you always have these two layers, a bottom layer for cluster communications and a top layer for cluster resource management. And in Heartbeat, those two layers did exist, but it was all packaged into one, monolithical glob. Yeah, right. And in about, what was it, 2003 or something, IBM and then still independent SUSE basically set out to write something that was worthy of being named a cluster manager on Linux in the 21st century, because Heartbeat had it was limited to 2 nodes, it didn't do any resource monitoring, it was something like Sun Cluster blew it clean out of the water. And that was, Andrew, that was pretty much what your main task was when you joined them. It got all these great new cluster resource management features like a policy engine and resource monitoring and extremely flexible configuration and blah, blah, blah. And then it was released, I think, in about 2007 or something like that. Except that people had kind of forgotten to provide a user interface other than an insanely arcane XML that was kind of unforgiving of typos.
Now,
Is that
nice.
SUSE promised one, the resources never eventuated to produce it.
Yeah, okay, right, yes.
Adding XML snippets into a shell script is a great way to configure things.
Repeat that, please.
So catting XML snippets into a shell script is a great way to configure things.
This man is insane, ignore him. Yes, but we all appreciate your irony, and I totally agree. And then there was another, so that was kind of a bad release decision in my humble opinion. What the folks then decided, I think this was something that you primarily drove, Andrew, was we're operating on this completely homegrown communications layer, and then there's something else that's actually standards driven. And why not go to that? And that was OpenAIS. And because of that, and because of a certain amount, certain limited amount of infighting among the project community, Pacemaker was sort of spun off or taken out of the Heartbeat project. Oh, are you?
I'm doing a little picture.
Oh, you're drawing a family tree?
Sort of.
Yeah, great. And it became its own project, which also made sense in a release schedule way, because Pacemaker was getting new features every week, and the communication layer was very stable. And ChorusSync basically grew out of OpenAIS. So it's a completely different code base compared to the Heartbeat communications layer. Okay, so that was the long version. The TLDR Facebook style it's complicated, but there is no real relationship between Heartbeat, which is now exclusively a cluster messaging layer, and ChorusSync, which is also a cluster messaging layer, and Pacemaker, which is and has always been a cluster resource manager, which used to be part of Heartbeat, is its own separate project and has been since 2008. So it has been for a while.
So will it work with both, or only now?
The question was, will it work with both? So as of today, Pacemaker supports both messaging layers, both Heartbeat and ChorusSync. The Pacemaker MCP is only supported on ChorusSync. On Heartbeat, it's basically the Pacemaker is always, the Pacemaker processes are always children of the master Heartbeat process, but it also doesn't have those locking issues.
Yeah, we never had the locking issues,
Yeah.
so
Yeah. So as of today, both are supported, but it is commonly understood that Heartbeat support will eventually go away at some point in the future. But when that point's going to be is kind of undetermined at this point.
At the point that we have a killer feature that we can only write on ChorusSync, or support on ChorusSync, then maybe Heartbeat goes away. But we haven't had such a feature yet.
Right. So, one more question?
Yeah. I get, when I do ChorusSync config tool-yes, I get ring 1 ID active with no faults, but ring 0 I get faulty administrative intervention required with a typo.
Yeah, I know. Well, that is a telltale sign of fix your network communications. So you told me earlier you were working basically on your own iron. So that clearly means that over that specific ring that it's complaining about, you've got a network issue.
Yep.
And the troublesome part, this is what I mentioned earlier, the troublesome part with ChorusSync releases prior to 1.4 is even if you now replug the network, you would still have to intervene administratively to fix it. And in ChorusSync 1.4.0 plus, that's thankfully now fixed. And it was actually a SUSE guy that fixed it.
That was Jiaju Yang, one of my colleagues from the Beijing office,
Yeah.
did the major part of the work on that.
Right. Okay. So we've got a working and replicating DRBD. We have a working and communicating ChorusSync cluster. And now what we're going to do is we're going to start the Pacemaker daemons. And we just do that with service. I don't know if it's actually service Pacemaker or Pacemaker D on Debian.
Pacemaker. And
Just
a typo in your, another typo in your.
You don't want your daemon in your init script with the same name.
Ah.
Yep, CRM on now. CRM on.
Yeah, and we have a nice little nifty handy utility called CRM-mon, which we can use to monitor the cluster status. We will take a few seconds here for the DC election to occur, but that's done now. So the cluster is now fully fired up. We not only have a CoreSync daemon running here, but it's also properly interfacing with Pacemaker. And what we see from CRM-mon here is we now have both nodes online. That is to say, they have properly checked into the cluster. We have also elected what we call a designated coordinator, or DC. That's the guy that basically calls the shots on what's going to happen next in the cluster. That does not mean, however, that we can only manage the cluster from that node. We can manage it from any node, but when we make changes, it's basically the change goes to the DC, and the DC broadcasts it out to the other cluster nodes. The DC is automatically re-elected when that node leaves the cluster. So it's nothing that we need to influence at any point. Andrew, is there a way to force a specific node to be a DC?
No.
There really isn't, is there?
The
Okay.
only reason we even tell you is because that's where the logs are probably more interesting.
Yeah. So for the recording, Andrew was saying the only reason that we're actually telling you is because that's where the logs are the most interesting, specifically because that's where we can do an excellent analysis. If anything goes wrong in the Pacemaker policy engine, that's where all the input files will be. And where we can do an excellent, what was it? Selena said don't use postmortem, review or whatever. Yeah, anyhow. No, so if something turns to shreds in Pacemaker, the DC is where we basically start looking for the policy engine input files and things.
What arguments did you pass to CRM-mon?
The question was, what arguments did we pass to CRM-mon? It's ARF. Andrew, can you please implement a -B option? I just want to do... So what's that do? So what does that do? CRM-mon just gives us a basic idea of what the cluster is doing at this point. It comes with a number. It's an incursus event-driven type of client that talks to the cluster infrastructure, and it comes with a boatload of command line options. In the absence of a B, ARF is my preference. So what does that do? -R shows us all of our resources that we have configured, not only the running ones. -F shows us a fail count, that is to say how often has this resource failed on this box, and -A shows us cluster attributes, which is also something that is usually quite helpful. All of that doesn't really do anything to our output at this point because we have defined neither resources nor cluster attributes. But what we're seeing is that both of our nodes are online. We have an elected DC, and we are essentially good to go. Now, for those of you who worked or tried to work with Heartbeat 2 at the time and ran away screaming because they were confronted with an XML-based interface, we have something much prettier and much more useful now, and it's called the CRM shell. And it just goes by CRM. You know, people were amazingly creative with the naming here. And what it is, it's a text-based, menu-driven, self-documenting, interactive cluster management interface. Those were a lot of buzzwords, but they're all actually included in that. So it's really, really nice. We have an online help. That is to say, in every level of the CRM shell, we can just type help, and we'll get an overview of what are the supported commands. We have nice little handy stuff like tab completion. We have the ability to script the CRM shell completely, so we can use configuration snippets that we can just import and use, and that is exactly what we're going to do right now. We're going to show you just a wee little bit of the functionality of the CRM shell. It's really an extraordinarily powerful interface. There's a lot of things that we can do with it, such as interrogate a resource or a node status. We can literally take a snapshot of the current cluster configuration, take a copy of that, operate on that copy, make tons of changes, and then only when we're done, re-import that into the cluster configuration. There's a boatload of things that we can do with this. And we're only going to show you, just a few of these. What we're going to do is we're going to change into the configure submenu, which when you open the CRM shell, you get by just entering the command configure, or the shell being fully scriptable. You can also just call the shell with the command CRM configure, and it will put you right into this submenu. And what we can do now is we could either configure the cluster from scratch here, or, and this is, we're playing celebrity chef here a little bit, so we've produced a bit of a mise en place for you. So we have these little configuration snippets, all of which live in /root with the extension .crm, and we're going to load those bit by bit to add our necessary resources to the configuration. The first thing that we're going to do is we're going to load one file that is properties.crm. So in the crm configure submenu, we can just do load and then either a full path load update, because we don't want to replace the SIP configuration. We just want to import the new stuff and update the SIP with that. And then the actual file name of the configuration snippet that we want to import. If that is a full path, an absolute path, then it's just going to take that. If it's a relative path name or a file name, then it's just going to evaluate that based on the current working directory, which is where we are right now. Okay? So load update properties.crm, and then we can do show. And lo and behold, we get stuff like syntax highlighting. So we can actually sort of visually navigate around this. So what have we added here? These things here, DC version, cluster infrastructure, expected quorum votes, is something that we cannot influence. That's something that just is being reported to us from the cluster. What did we add? Two things. One of these you should actually use in production. The other, if you use in production and I catch you, I'm going to slap you. So no quorum policy means, no quorum policy equals ignore means even if you're losing quorum in the cluster, still continue to run resources, which is what we have to do in any two-node cluster, failing which, if we lose one of the nodes, there's only one left. That one node does not form a core 8 cluster, therefore it doesn't do anything for us anymore. If we set no quorum policy to ignore, which is what we do which we basically always do in a two-node cluster, that means we can always lose one node and stuff is just going to continue working on the other node. And Stonith enabled, so Stonith, for those who don't know, is an acronym that stands for shoot the other node in the head. That is the Linux HA/pacemaker term for node fencing. And it is a vital stability and security feature to have node fencing enabled in your cluster. We're only disabling it for testing purposes. And it's fine if you do this in a testing environment, but just don't go to production with it. Why is it necessary? Several reasons. One, if you're using shared storage and you have one node that is potentially still accessing that storage, there's only one secure or safe way to remove that node from that storage, and that is to essentially kill it, or at least kill it and then bring it back up from the dead. So that's one. Even if you're not using shared storage, you still need Stonith, because we have to evict nodes from the cluster where resources do not stop properly. Because for the same reason, it might still have access to cluster resources. It might do things that it's not supposed to do. So if at any time we're trying to shut down a resource and that shutdown fails, it's just the shutdown operation, then we have to evict the node from the cluster. Hence, always use Stonith enabled equals true in production.
And there's various Stonith devices that you can use. You can use Ethernet PDU things. You can use ILO devices, IPMI.
IPMI being the most common at this stage, I would say, because it's pretty much impossible to buy a server these days that doesn't come with an IPMI BMC with a LAN plus interface that you can connect to over the wire. Okay, so what the load update properties.crm did for us, it set these two properties. No quorum policy equals ignore, Stonith enable equals false. What's nice about the CRM shell, we've imported the stuff, we've had it shown back to us, but in order for it to actually become active, we actually need to commit this. If we don't commit it, then that update gets thrown away. That update at this point doesn't do anything for us. We now actually have to add resources. Okay, like I said, what's a resource? Anything that the cluster manages. We have very, very simple resources such as IP addresses, which are simply brought up and brought down on nodes as needed. We've got file systems, meaning we mount this here, we mount this there. But because this is LCA and you're a smart crowd, we're not going to we're not going to occupy ourselves with something that simple. We're just going to dive headfirst into master-slave sets. Master-slave sets are an extended type of resource that is unique to Pacemaker, and it's such a useful feature that I fail to understand why any of the non-open source competitors haven't implemented it yet. Master-slave sets are a special variant of what Pacemaker calls clones. Clones themselves also being exceedingly useful. Define a resource once and then just tell the cluster how often do you want it, how many instances of it do you want in the cluster, and Pacemaker will do that for you. As in, we can use clones to manage an entire IP range. As in, I want 5 IP addresses starting with 1, 2, 3, 4. And we just define this clone resource once, and we're telling Pacemaker, okay, I want 5 instances of this, and it will make sure that we get the full range from 1, 2, 3, 4 to 1, 2, 3, 9 in the cluster, which is really, really nice. And master-slave sets are basically clones that aren't equal, but clones where one of the nodes is sort of the higher up. Okay, dictator for life. Well, not for life, but dictator for as long as Pacemaker decides.
Dictator till failover.
Yeah, exactly. And we have, and that's what we use for managing DOBD resources under Pacemaker. Because there's 2 things that Pacemaker has to do. It has to bring up the DOBD resources on both of the nodes. This is what we did earlier with the DOBD atom up command manually. It has to do that whenever it needs to interact with the DOBD resource. But it also has to select one master node, and that master node then becomes the DOBD primary. Also something that we did manually earlier, but this is of course something that we want to automate in cluster management. So what we're now going to load update is our DOBD.crm. And the warnings here are a little bit excessive. We can safely ignore them for now. And this is a little more complex now. So what have we defined? We have what Pacemaker calls a primitive. That's just a regular resource for our DOBD. It has an identifier, a name. We call it pdrb MySQL. It has what we call a resource agent, or you could also call it a service agent or a resource type, what have you. In Pacemaker parlance, it's called a resource agent. These have a class, a provider, and a name. In this case, it's the class OCF. The provider was named Linbit by the DOBD authors, and DOBD is just the name of the resource agent. In case you're wondering about this provider thing, that basically maps to a hierarchy in user lib OCF resource.d, and then we have one directory per provider, which is a nice way for third parties to just package and ship Pacemaker integration resource agents. We need to name the DOBD resource, which is MySQL in our case, and we also let it monitor this resource in specified intervals. And we then wrap this primitive into one master-slave set. Okay? The intricacies of which are not necessarily something that you need to worry about right now. What's important is we want 2 instances of this thing. Remember, master-slave set is basically a subtype of a clone. So we can define, okay, I want 2 clone instances here. Only one of them can ever become a master. And the notify thing is a nifty little Pacemaker feature where individual instances of clones can notify each other of, okay, this is what I'm doing right now. This also is something that I think is completely absent from other cluster resource managers. Another very, very nifty Pacemaker feature. And when we commit that, now something is actually going to happen in our CRM-mon output. There we go. Ah, that was quick. So we brought the DOBD up on both of the nodes, and we in Pacemaker selected one of the nodes, in this case arbitrarily because the promotion scores were identical. It just made that thing the DOBD primary, or in Pacemaker parlance, the master, on our node named Alice. And that is something that we can easily verify, just as we did earlier. We can do a cat proc DOBD on Alice, and we shall see its primary and everything is as expected. Okay? So now that we have that, we are going to add the file system that we have created on this DOBD resource to our Pacemaker management. Okay? And for that, again, we have a load update fs.crm. Okay, and we want to show that as well. And here's something that is one of the most powerful pacemaker features, but also one of the most challenging to basically wrap your head around. This up here is relatively straightforward. That's just a primitive resource, a simple resource. It just manages a file system. It has a few configuration parameters. We have to tell the cluster, okay, this is the device that you're going to mount. This is the mount point that you're going to mount it to. We're just going to use the standard default MySQL data var MySQL. And we also have to tell it the file system type. In case you're wondering why that is the case, we have a little bit of don't shoot yourself in the foot type magic in here. If you were to clone this thing, then we would check whether it's actually a clonable file system, like GFS or OCFS2, or Gluster or Lustre or what have you. And we're also monitoring this thing every 20 seconds. So every 20 seconds, we check whether that mount point is actually still there. We have a little more intricate monitoring as well, which we could optionally turn on, such as, okay, try to actually write something to this file system every 20 seconds, just to see whether it's in fact not just mounted, but it's actually writable. So that's the simple part. The slightly more complicated part is this. We collectively call this constraints. We have two constraint types here, a collocation and an order constraint. The collocation constraint, which is at the top here, means run this resource, this one, the file system that is, on whichever node currently has that resource, that's the DBD master slave set, in the master role. In other words, mount that file system only where the DBD is primary, in this case. Okay? And that just implies do that on the same node. And the order constraint, lo and behold, specifies an order. That is to say, first promote the DBD master slave set to the primary role or to the master role in pacemaker parlance, and then start up the MySQL file system. I'm sorry, the file system that's going to host our MySQL data. Okay. Now when we commit that, we're going to see some more magic happening in our CRM-on. And luckily, well, not luckily, but quite intentionally, the file system has now been started on the same node that already has the DBD device in the primary role, or in pacemaker parlance, the DBD master slave set in the master role. Again, something that we can easily verify by a simple mount on Alice. So look at that. Okay, it's all there. And now, before we actually enable this thing as a MySQL, a highly available MySQL cluster, what we of course have to do is we actually have to initialize the MySQL database, which we do with MySQL install DB. And yeah, you can do that, but that's actually the default data dir. So we're already mounted where we're supposed to be. So yep, there you go. And it will now just install the MySQL system tables into varlib MySQL, which previously was an empty file system, empty mount point. Okay? Now, we can do a quick ls in varlib MySQL. Okay, and it's just the MySQL directory in there, and in that's the MySQL default database that I'm sure you're all very familiar with. Okay? And now we're just going to add everything else that we need for a MySQL cluster to this thing. And here again we have a pre-made MySQL.crm thingy. And there's a few things that have happened here. We do a show again here real quick. So firstly, we have now added an IP address, a cluster IP address that MySQL can bind to with the PIP MySQL resource. And we have also added an actual MySQL resource that monitors the MySQL daemon. Okay?
May I ask a question here? I've asked you about this in IRC, but I think you may have missed it. Is there a way to specify which specific interface that IP address? I know there's lots of smarts that tries to figure out which interface it's meant to go on.
So the question was, is there a way to explicitly specify which interface this thing is meant to be listening on? Yes, of course. There is a NIC parameter for the IP adder 2.
Can it be different for each host? Like it might be NIC1, ETH0 on one host and ETH4 on a different host?
No, because the SIP is always cluster-wide. But if you do that, and assuming that you already have a node IP address on that interface, findIF will do the right thing for you and therefore bind to eth0 here and eth1 there, if that's what the configuration is. Yeah, yeah. Okay, so we've added these two things, and we've now tossed all of that into what in Pacemaker we call the resource group. Okay, resource group. We basically put everything into one group that that MySQL requires. It needs its data directory, therefore it needs its file system, it needs its IP address, and the MySQL daemon itself. And this is something that's really, really cool about the CRM shell. Note that we had created these collocation and order constraints earlier, and they apply directly to the file system resource. Now I'm tossing that file system resource into a group, and the referencing constraints are getting properly updated by the shell, which is nice. You know, it's just one less way of shooting yourself in the foot. It's just a helpful little shortcut. Do we have a question?
Were you telling it to mount the file system before starting MySQL?
Okay, where do we tell it to mount the file system before starting MySQL? Groups by default are ordered and collocated. That is actually something that you can turn off.
Don't do that. Don't do that. Just don't do that in a group.
Quoting Andrew from memory, uncollocated groups are, I think, an abomination was the term that you used.
Yeah, it was.
Yeah, you might have even used less uncertain terms. So by default, the groups are being started in this order and stopped in reverse order.
It's basically a shortcut for order and collocation constraints.
Yeah.
Anything in a group is always ordered together and collocated together. So you could write that group statement with location constraints if you wanted to, but there'd be like 6 of them.
Okay, and they're now updated and everything, so we can commit this. And our initial MySQL startup always takes a little bit longer because it, of course, creates the InnoDB data files, etc. Timeouts on start, on stop, by the way, are, of course, configurable. And we have done so in the example configuration that you are getting. Why is this important? Pacemaker actually enforces timeouts. So in other words, if your resource does not... Oh, what was that?
That was a problem.
Yeah, one of your boxes just went offline. How'd that happen? You did what?
I didn't fancy. This is why we have these T-shirts. Actually, this is what your hardware should look like.
Yeah. So that you're reasonably highly available most of the time.
Yes.
Yeah. Look.
They purport to be online again.
Look at that. You know, we've recovered. Hey, you know, it's an HA cluster. It's supposed to do this thing. So what we just showed you is failover. Huh? It wasn't planned at this point, but it just shows you that this thing is working. No, what I meant to say actually earlier is Pacemaker does enforce timeouts. So if your resource fails to start up or shut down in the appropriate time, Pacemaker will register that and initiate failover as needed, or try to restart, initiate failover, whatever is configured. And specifically for something like databases, that is something that you want to take into consideration. Databases are not exactly applications that are known to shut down fast. Okay, so the shutdown time that it takes for an orderly shutdown of your database is something that you definitely want to take into account and want to take into consideration in your Pacemaker config.
You're better off setting timeouts that are too long than are too short, basically. Lars Morawski-Bree had a good blog post about that somewhere.
Oh, that was his least worst case thing. Yeah. I think you only need to Google for least worst case, and that's probably it. Okay, so we have a working and running cluster. Let's go to lunch. No, not quite. Not yet. What have we set up here now as of this point? we have a working HA cluster that will survive node failure. If you kill one of these nodes now, and you can do so by simply using your libvirt interface, whatever you prefer, and kill one of these nodes, it's going to fail over to the other node. However, it doesn't only do that, but it also does resource monitoring, which very often is even more useful because individual resources tend to fail more often than whole nodes. Okay, so let's give that a quick shot here. If we open our terminal on our node Bob, and we do a simple PS, there we go. Yeah, whatever you prefer. Okay, so we've got our MySQL daemon here, and what does it do? Pit file equals var. Well, anyhow, let's not worry about that right now.
It's good truncated.
Ah, okay, thank you.
Yeah.
That scared me. So it's doing exactly what we configured it to do. So not only is it running with the appropriate configuration, etc., but it's also binding to that specific cluster IP address that we have, that we've just configured. Can I get another CRM configure show real quick? Okay. And where's our MySQL? Oh, up here. We have configured resource monitoring for this thing. Okay. So if you could just get a CRM mon RF or something on Alice. Yes. Okay. We already have that. Great. And now what we can do is we can just cut over to, what is it, Bob? And just do a quick, whatever. Let's send MySQL. Monty is going to cringe at this, but we're just going to send MySQL a term signal. And the term is actually fine. Killing it is really evil.
You should always be able to just kill your MySQL if you're running on top of HA setup, because your power might just go out.
Yes,
so
of course. Yes, but I'm going to go into that in just a little bit. There's one additional consideration that you want to make in your HA setups. But okay, let's just kill that puppy, and then cut over to the other box here.
That's a clean shutdown, by the way.
Yeah, but still, it's something that Pacemaker has to detect as a resource failure and recover from it, as it's doing right now. Okay. So it brought the resource back up, and this is why I always use this CRM mon-f flag. It not only tells us when a resource is stopped, it also tells us when it's running, because it's successfully recovered and has a fail count. So it actually tells us how often has this resource failed on this node. And we can do nice little tricks like let this, if that resource fails on one node, like more than 5 times, don't bother recovering it in place anymore. Fail over instead to the other node because we're suspecting that we're having a hardware problem. And it's very, very configurable. We can do all sorts of things with this. There's a number there's really a lot of really, really cool stuff that we can do with this. So when you have this, have fun with it and break it. Okay. When you have this, you can kill one of your nodes and watch it fail over. You can bring that node back up. You can kill one of your resources. You can do stuff like, for example, removing the IP address, and then you'll notice that because the IP address is being recovered, there's also that one dependent service on it, namely MySQL, that's being recovered. Because that's not too happy with no longer having its IP address that it's bound to.
I'm going to do this again.
Yeah, there we go.
My brain's gone blank. What IP address is it?
Here, that's the secondary one. That one. The 110.
110.
There you go.
Is that going to work?
There you go. And that's failed now, and now we need to cleanly shut down MySQL and bring everything back up. So that's, it enforces these dependencies nicely.
I might just, if you can still see that, you can see the 2 resources that we've failed. I killed MySQL twice before, so its fail count is 2. And we killed the IP address once. So its fail count is 1. When it went down and was restarted, MySQL was cleanly stopped and started by Pacemaker, so it itself doesn't have another fail count because it wasn't the dead thing.
Yeah. Okay. One thing that I just want to mention, because I think it's really, really important for everyone to keep that in the back of their heads when you're operating an HA cluster. So as Monty was saying earlier, in an HA cluster, it's perfectly acceptable to kill -9 something like a MySQL server, because after all, when we lose power or when we have some catastrophic problem on that box, we don't ask MySQL to shut down cleanly either. So that is something that we have to recover from. And that is something that's perfectly doable if you are not insane enough to put your production database on a non-transaction capable database engine like MyISAM.
Don't run anything on MyISAM, stupid.
Okay, anyhow, yeah, true. But well. This is really, really important. If you have an application that is inherently not crash safe, then Pacemaker, CoreSync, DRBD, what have you, are not going to make it any more crash safe. It's just not capable of doing that. If conversely, you have an application that is crash safe, if you configure Pacemaker, CoreSync, DRBD correctly, there is no way that's going to get any less crash safe. Okay, so that's one thing that's really, really important. And the other thing is, and this is specific to InnoDB, but the same concept applies to a number of other daemons and services and what have you. And that is, when you are optimizing something like a database for performance, what you typically do is you follow a pattern of write to disk as late and as rarely as possible. And any database worth its salt, even when you're buffering a lot, when you're caching a lot, when you're keeping lots of stuff in memory for a long, long time, and then actually write to disk at the latest possible opportunity, they will recover from this, but they will not make any guarantees for how long that's going to take. Okay, and if you've got say a 96 gigabyte RAM server, and you're following this rule or this suggestion that you find in many places of use an InnoDB buffer pool that's 80% of your RAM, and you've got a really, really busy database that's being hammered a lot, that is a lot of dirty stuff that you have in your database that you then need to recover to a consistent state from, and that can take a long, long time. And even it might take such a long time that you're breaking your SLAs. At which point, people are not going to be happy about you running an HA cluster when it takes you hours or days to recover that critical service that you're running. So this is something that you just want to keep in the back of your head. Certain rules for performance optimizations are rules that you have to reevaluate when you're running it into an HA cluster, because downtime is bad. Downtime is a lot worse than having reduced performance for a certain time or even permanently. So that's another thing that you just want to keep in mind. Before we go to questions, because we only have 5 minutes left and I don't want to stand between you and your lunch for too long, we have a cluster HA and storage replication BOF this afternoon, right after lunch. So if you haven't had enough of your HA fix as of now, join us after lunch. We're going to be in Studio 2, which is all the 3 studio rooms are to the left of the Caro Theater. So where you went for keynotes this morning, if you haven't been to a studio before, it's like you walk to the main, before you walk into the main keynote lecture theater entrance, you make a left and a right, and there's the studios. They're all clearly marked. We're going to be in studio number 2 as of 13:20 this afternoon. Andrew's going to join us. Everyone else is certainly welcome. Bring your coffee or whatever you'd like to bring with you. Grill us with questions. Tell us we're stupid. Tell us we need to fix things. Whatever it is, we're always happy to get direct feedback from people who use this stuff and who know what they're doing, and LCA is a perfect crowd for that. So please consider yourself invited to that, and now we'll be happy to take any remaining questions.
We have 10 minutes of question time. So
Oh wow, did we just steamroll over you?
Ours is broken. So that's the question. Ours didn't come up.
Oh, yours didn't come up. Yeah, okay. We can...
I can try to rephrase that. Do you have any suggestions on debugging resources that won't start and why
Oh, look, Andrew, we're talking about logging now. The whole stack has a reputation, a completely undeserved reputation for having verbose logging. Okay.
I'm not disagreeing that we want to.
Yeah. The thing is that in many standard configurations, Pacemaker and related services just completely flooding the logs. Therefore, my knee-jerk answer of look at your logs and they will tell you is not going to help you too much. Specifically, do you know which resource it is that isn't coming up?
Yes.
Yes. Okay. In that case, you can just grep for that specific resource agent name in the syslogs, because everything that's actually being logged that comes from a resource agent is prefixed with the resource agent name. So that would be if your IP address is not coming up, that would be IP address 2, etc. But
you want to look at that in the logs on the node that the IP address failed on.
Yeah, correct. But I will be more than happy to spend some time with you going through this and debugging this and troubleshooting this, because after all, that's what we're here for.
That's already helpful.
There we go. See?
Okay, I've got a different interesting problem. I noticed, as I said, I'm doing this on production hardware, and we're using Debian Squeeze, which is using, by default, Pacemaker 1.09 and Corusync 1.2, or the other way around. So I realized I need to be using backports. So I went to the backports version, which gives me the same version you have here, which is much better. And in the process, when I did that on one of the nodes, I just did an upgrade. On the other node, I actually ended up, because of problems with the packages, I ended up uninstalling Corusync and Pacemaker and reinstalling them. And now I have no CIB, and the CRM tool just won't connect and won't let me load the CIB back in from the other node.
Okay. So I guess the question is more related to, okay, what do we do on uninstall and upgrade and whatnot? What can we do with individual nodes that will or will not break the cluster? Generally speaking, if you are uninstalling Pacemaker and reinstalling it, or doing an upgrade, or what have you, when you fire the services back up, and I presume you have, when you fire the services back up, it's going to check back into the cluster, the communication rings, and the SIP itself, the cluster information base, the internal representation of the cluster configuration and status, is versioned. So it will basically recover its copy of the SIP from disk when it comes up, and then it's going to realize, oh wait, we have something much newer on the wire, and just going to use that. Okay, so generally speaking, if you uninstall Pacemaker and put it back up, and uninstall, reinstall, and then restart the daemons, it should just rejoin the cluster. And that's what it typically normally does. And if it's not doing that for you, again, something that we can do in the BOF. If the BOF turns into a hands-on hackathon, that's perfectly fine by me. Another thing that I forgot to mention, an exceedingly useful feature in Pacemaker, and this is something that people that come from Solaris clusters seem to really, really love, is maintenance mode. In maintenance mode, we're telling Pacemaker, keep your hands off of all resources. That is to say, it's not doing any monitoring anymore, it doesn't do any recovery, it doesn't do any what have you, but I can now literally rip the guts out from the entire cluster infrastructure. So I can shut down the Pacemaker services, I can shut down Corusync, I can upgrade the binaries, I can bring them back up, etc., and my services are going to continue to keep running. So in this case, you would be able to, like, for example, you put this cluster in maintenance mode, your MySQL continues to run, you have your virtual IP address, etc., and now you shut down Corusync and you completely upgrade it with a new version and you bring it back up. You can even do a live, no downtime migration from Heartbeat to Corusync if you want to. So you put the cluster in maintenance mode, you shut down your Heartbeat processes, you bring up your Corusync configuration, fire up Corusync, and then take the cluster back out of maintenance mode, and boom, you're done. And that's really, really helpful. So yeah, CRM configure property maintenance mode equals true. Poof, cluster is in maintenance mode. All the resources are unmanaged, etc.
And where is that, Bob?
The buff?
Where's it located?
The buff is going to be in Studio 2, which is over in the same building as the Keynote theater.
Just a short comment. Just make sure that CRM mod is happy that it redetected all the resources running before you terminate.
Yeah. Yes. So Andrew was saying check CRM on to make sure that everything is actually working as expected. When we come out of maintenance mode, Pacemaker does what we call a reprobe. So it basically checks all the resources for their current status. And if a resource should have failed in the meantime, then it recovers that again.
So I've just put it in a maintenance mode, and I've stopped Pacemaker on Bob. CRM on Alice is not aware what's going on.
Yeah.
That's fine. That's what you want.
And it's saying stops because you've got Stoneth disabled. If Stoneth was enabled, it would say, well, as far as we know, it's still running on.
Yeah. But still, the service itself, which is MySQL, which is what we normally care about, is still running. Pacemaker services are, and ChorusSync isn't at this point. Oh, you just stopped Pacemaker. Okay, never mind.
Pacemaker,
that's fine. That's fine.
You know, just it's enough. And if I start that up again, now it knows about the state that all those resources are in, and now I can safely take maintenance mode off.
False. There you go.
And that's an example of just running not using the interactive mode of the shell too. You can just clicky, clicky, boom, done.
All right.
Florian, you'll be happy to know I just pushed the GitHub there. Name changes.
So you fixed your broken node names in IPBX. Yes, thank you. There's one convert. Woo. Okay. I think that's just about it, time-wise. And like I said, we don't want to be between you and your lunch. Thank you very much for your kind attention. We hope to see many of you in the BOF. Again, that would be at 1320 in room Studio 2. Thank you very much.